everybody, welcome to another episode of Daily IoT. We are back, still on the hockey project today, and today what we're going to talk about is I've been working on this screen. I've been spending hours and hours, probably 10 hours, getting our e-paper display to work, but we are there, and I am excited to show it to you. And also, need my green. I lost my green. Come on, man. I found it. We can draw the rest of this arrow. No, we can't. I don't know why I drew that. We cannot draw the rest of that arrow. Sorry, it'll just have to stay there for now. But what we do have is controlling our e-paper display from the particle cloud. We were controlling our simple 7 segment display, but now what we have is, I don't know if you can see that, it's Marc-Andre Fleury's stats from last season. How we can update these with the press of a button from the particle cloud. Very, very cool. And so we're just gonna briefly talk about today what we had to do to get this sucker to work with the particle photon, but we're there, and so let's go over that now. So the first thing that we need to talk about is how to connect the display to our particle photon. And for that, Crystal Font sells this little breakout board. It's the one I told you about that's way overpriced because there's a bunch of external components that the display needs to be able to connect to things like microcontrollers. But once you have all of this external stuff that's on this red breakout board here, all we use is the SPI communication protocol. And so it's just a few lines going from the breakout board to the particle photon in addition to power, which is 3.3 volts in this case. And then the display just slides into this little connector here. And again, doesn't require any power to maintain the display. Right now it's unplugged and happily holding Fleury's last season stats on it. And so I will post the schematic for how this is connected up, but really simple. Just it's a mess of wires, but it's not a real complicated mess of wires once you know where all the pins go. And so that is how we connect it to the particle photon. With the display connected, I have modified a bunch of the code. I went through the code before of how we set up this simple segment display, but now not most of it, all of that is gone because interacting with the e-paper display is completely different than interacting with that simple 7-segment display. However, the code is still fairly compact. I brought in a couple of libraries. I brought in the Adafruit library that was ported to Particle, as well as a library that I found for this e-paper display called the GXEPD library, which is not part of the Particle ecosystem, and I had to do a bunch of changes to it so that it would work within the Particle ecosystem. I'm not going to go over all of that code. I've posted it to GitHub. I put a link down in the description so you can go check that out. But the short version of it is I had to bring a bunch of pieces together, but this is the great thing about open source. All of the pieces were out there. I just had to bring them together and then make some tweaks. I didn't have to write anything from scratch. I did not go with the Crystal Font's example code that they have. The code that they wrote works on bitmaps only. So every update to the display has to be done with a bitmap based on the code that Crystal Fonts gives you, which means if you want to change 13 wins to 14 wins, you need a 1 bitmap and a 4 bitmap or a 14 bitmap. And so it gets messy. What I wanted was what the Adafruit graphics library offers, which is this way to just draw simple shapes and do simple text output. All of that now enabled on the screen. We can draw shapes, we can do partial updates, print out text. It all is working very well. And so let me just walk you through the code very briefly, the new IoT Hockey INO file, and see what we have here. And so if we come in here, you can see we have a bunch of new include statements. This is all of those libraries I was talking about. The GXEPD library actually has a support for our specific screen, which is really cool. And what that does is it inherits from the Adafruit graphics library. And so we have to import that as well. And then the fonts from Adafruit so that we can write on the screen. Now, I created 2 bitmap backgrounds. The one that you've seen is the Fleury one. I also have a McDavid version, which is broken out into 4 windows for stats that I can track for him. And then because we have these libraries, setting them up is as simple as doing this GXIO-SPI. And so this is the communication layer that we'll use to talk with the display. And then here's our screen object itself that we call display. And then you can see display uses the IO that we just newed up right here to be able to talk to the display. So nothing crazy there. This is these defines here are for updating a specific version, because on this e-paper display, when you update the entire display without doing a partial update, it does this flash reboot type thing, and it's really gross. Partial update just says I'm gonna update a window, and so that flurry template that we have that has like his name and the stat headings and stuff, that always stays there, and all we're updating is the specific stats. And to do that is just this update stats on display function. And what we do is we take in, because of the way the library works, you have to take in this void pointer and then reinterpret cast it to a stats struct that I defined up here. And then we basically just take the values out of the struct, sprintf them into strings, and then do a little bit of set cursor magic. And really all set cursor is doing is, once I had that template bitmap displaying on the e-paper display, I had to, it's just trial and error, set the cursor to different points to get the numbers to line up right where I wanted them to. And so there's no magic. You can see these numbers at 5, 55, 72, 55 right here, and then 150, 155. That was all figured out through trial and error, just seeing where I wanted to print the stats out so that they looked nice on the display. And so that is really all it takes. The initialized screen does things like set the font and the text color and the text size and things. And you can look at all this on GitHub. I won't bore you with that now. And we have this update tracked stat, which was our particle cloud function from a previous episode. And you can see that it has changed a little bit. What we are doing now, the problem I ran into, and the problem I run into on all of my projects, is I write software for a living. And so as I start writing firmware, which is just a version of software, is I start going through all of the edge cases and trying to make it, hardened and secure and all these other things that you think about when you do this as your full-time job. But then I remember that I'm not making a product here, I'm just doing a project. And those are levels of polish that you certainly could and should do, but for the purpose of me trying to learn new things, I don't have to spend hours doing that. It's that old saying of like 10% of the project, or 90% of the project takes 10% of the time. It's that last 10% that takes 90% of the time. That's what I started to fall into here. I was importing a JSON library to be able to send, any kind of stat I wanted to and have it parse it out. And then I was like, forget it. Let's just simplify it. And so all I do in this update track stat is I take a simple comma delimited string from the particle cloud, parse it out using the index of the commas, and then turn that into Marc-Andre Fleury's goals against, his save percentage, and his wins. And then all I do at that point is I print it out. This is for debug, this line right here. And then I call process new stats. That's that function that we looked at above to display the information. So to show you how this works, let me pull down my particle console here. And I'm in my microcast Photon. I have my update stat function just like we showed before. And you can see I have his stats here. And so let's change his goal, his GAA to 1.23. His save percentage, we're gonna pump up to 967. And we'll make him have, instead of 18 wins, we're gonna make him have 48 wins, which I believe is tied for most all time in a single season. And all we have to do at this point is hit this call button, and if we watch the display, it takes about 2 seconds. Well, actually, nothing's gonna happen because I don't have it plugged in. So let's plug it in. Okay, so once we plug it in, you're gonna see the screen's gonna refresh and blank out. There are no stats displayed there because the season hasn't started and I'm not pulling those. We still have to build that piece of it. But now if I hit this call button, click that, boom, just like that. You can see all the stats show up, and that's it. we got the display working. There is a ton of polish that I could still do on the interaction with the display and abstractions to make it a lot cleaner, but I think there's enough in the code on GitHub that you can now take this and modify it for any player, any stat that you want. It's really quite simple. All we do is we take a bitmap of what the background is, sort of the template. In my case, it's this, this goals average against, save percentage, and wins, and Fleury's name right there. That's all a bitmap that is fixed, and then all we're doing is we have this update window right in here that are the numbers. And so that's really all there is. You pick your player and the stats that you want to track, you create a bitmap template that you load up on the screen at boot up, and then it's just modifying the window of where the stats are actually displaying. And that's it. That's all it took. I say that's all it took, like 10 hours of me messing around with the code. But now that I have it and I packaged it and I put it on GitHub, somebody else can take it, and in a matter of minutes after you hook up the display, you can start displaying things, printing things out to it, and getting on your way. Now this one was a little bit tougher. I mean, there were a lot of things that we had to pull together, but it's there. If you have questions, you look at the code and you're not sure how to do something, please stick it in the comments below. I'm happy to help and try and figure out how to get you over any hurdles that you encounter. And what we're gonna do next. So now, you can see it in the background, we've got our screen, we can update it from the cloud. Now it's a matter of how do we track the stats, and from the NHL API, we talked about how that works. How do we take those stats and now full end-to-end get those things flowing down onto our screen? And I have been messing around with this with LoSant, and I am so excited for the next few episodes. I'm not sure how many I'll turn it into, but the LoSant backend on this is going to be amazing. I've put together some workflows here that we're going to implement in LoSant, and I think it's going to be really slick for being able to add players to track stats for, and we're not going to have to write any website code for this. So a lot of times for things like this, you would need something to interact with the NHL API. LoSant is going to do all of that, and I am really excited to get some episodes going for that and working our way through that side of it. And so that is the latest update. Progress is coming along nicely. Hopefully soon we're going to be boring out the puck and getting this in. I'm really excited about how this is coming along. Question of the day. There is no question of the day. I just couldn't come up with one. Super lame of me. But I still appreciate everybody watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.